In this video, we will be continuing to graph rational functions such as these. I am losing my voice, so bear with me. We've already done number 1 and 2 in previous videos, and in this video we're going to do number 3. Alright, so first we are asked for the x-intercepts. As long as there's no number on the end, like a +5 or something, we can find the x-intercepts by setting the numerator equal to 0. So I can take this and set it equal to 0. The first thing I would do is just go ahead and distribute that negative sign. So that's going to give me negative x squared minus 3 is equal to 0. Then I would add 3 to both sides. So now I've got negative x squared is equal to 3. Now this is like a -1, so I will now divide both sides by -1. And that's going to give me x squared is equal to -3. Now if I try to unsquare this by doing the square root, I've got the square root of a negative number. Okay, that's imaginary. That's going to give me x is equal to positive or negative I radical 3. Alright, imaginary numbers don't show up as x-intercepts on a number line. So that means there are no x-intercepts. So we'll just put none. It'll be interesting to see how that happens. Anyway, time for the y-intercept. To find a y-intercept, just substitute 0 for x. So if I put 0 here and here, so those are gone. So that's going to give me, I've still got this -1 here, so that's going to give me -3 and over -25. So that's just going to be 3 over 25. So my y-intercept is going to be 0, 3 over 25. Okay, that's a really small number, so when I graph that later, it's going to basically appear to be, it's almost 0, 0, but it's actually a tiny bit above that. Alright, next let's find our vertical asymptotes. You will find the vertical asymptotes by setting the denominator equal to 0. If I set the denominator equal to 0, one way I could solve this is by factoring. This is going to give me x plus 5, x minus 5. But that's going to give me x equals -5 and x equals +5. So those are my vertical asymptotes. Alright, so let's go ahead and graph those. Alright, and there they are. So now horizontal asymptotes. When we ask about horizontal asymptotes, we must stop and consider the degree of the numerator and the degree of the denominator. Which one of these three situations are we in? If the degree of the numerator is less, then y equals 0 is the horizontal asymptote. If the numerator degree is equal to the denominator, then we divide leading coefficients. But if the numerator degree is greater than the denominator, then there will be no horizontal asymptote. Though there may be a slant asymptote if it's exactly 1 greater than the denominator. But we'll worry about that later. Okay, so what's the degree situation here? Well, looking at the numerator, the degree is 2. The denominator, the degree is also 2. So when the degrees are equal, that's when we must divide the leading coefficients. Now, again, I'm distributing the -1. What we have here is negative x squared, negative x squared minus 3 over x squared minus 25. So the leading coefficients are invisible, but it's -1 over -1. So that's why the horizontal asymptote is going to be -1. Y equals -1. So let's go ahead and draw that as a dotted line. Now, before we can answer any more questions, we need to go ahead and plot a bunch of points and see what the graph looks like. So I'm going to record every point that I choose to investigate on my table of values right here. So the first thing I'm going to do, though, is look at my vertical asymptotes. The first values I always pick are just to the left and right of my vertical asymptotes. And I mean just barely to the left and barely to the right, decimals, in fact. So here I have a vertical asymptote at -5. So just a little bit to the left would be -5.5. Let's always use that. So we'll do -5.5. And just barely to the right would be -4.5. So let's definitely do that. Okay, let's do the same thing and pick values to the left and right of the other asymptote, which is at +5. So that would be 4.5 and 5.5. Alright, so I will definitely use 4.5 and 5.5. So you should always do that. Always use values just a little bit, decimals to the left and right of the asymptote, because extreme things happen near the asymptote and you don't want to miss it. But putting that aside, we need a few values in this zone, a few values in the middle, and a few values on the right. So in addition to the value I just picked, I'm also going to do -6 and -7. Okay, so I'll do -6 and I'll do -7. Alright, I've already got the y-intercept, but I'm also going to do, let's say, -4. Okay, I'm going to do -4, and then I'll do +4. I still like to be close to the asymptotes, spread out as much as possible, so I'll do -4 and +4. Alright, you see I'm running out of space on my chart, and you also see I can't draw a straight line, but stop judging me. You're very judgy today. Okay, so -4, +4. Okay, I'm also going to do, so now I need a couple more points on the right. So I'm going to do 6 and 7. Alright, this is a good group of points. So I'm going to find all the y values. I'll show you how I get one of them, and then I'll do the rest off camera. So I'm going to go to the table feature of my TI-30 XS multi-view, and I'm going to type in this equation. So this whole -x² + 3 situation over x² - 25. Okay, now I recommend putting the calculator in ask mode, so you can just do all the decimals you want. Okay, so now I can type in -5.5 and -4.5. So -5.5, -4.5, and 4.5. Okay, those are the first three values I wanted. I can just type them in, and it'll be more meaningful if I get decimals. So if I toggle this, I see I've got -6.3. Okay, and if I toggle this one, I've got 4.9. It's going to round up. And then if I toggle this one, I've got +4.9. Oh, well, okay, that was silly. Obviously, they're the same thing. Okay, so I'm going to do that for all of these values, but you don't have to watch me do that because that would be quite boring. Unlike the rest of this video, which is thrilling. Okay, so these are all the values that I pulled off the calculator. Now I'm just going to take those values and graph them on the graph. Alright, so here's an image of what all those points look like once they're plotted on the graph. Alright, so once you draw the curves that are suggested by the points that we plotted, they should look like this, approaching the asymptotes at every end. Now we can do the domain and range and such. So first of all, the domain, which goes from left to right. This graph goes left forever and it goes right forever, and I even have this part in the middle, but the vertical asymptotes are being skipped over. Alright, nothing is touching these vertical asymptotes, so they must be eliminated from the domain. So this part of the graph goes from negative infinity to negative 5, x value wise. So I've got negative infinity to negative 5. And then the middle part of the graph goes from negative 5 to positive 5. And then the right side of the graph goes from positive 5 to infinity. We're talking x values, so it goes from 5 to infinity. Okay, that's the domain. Now the range, we have to be more careful because there are no values at the horizontal asymptote, but it's a little more complicated than that. So the range is the y value, so we're going to look from bottom to top. Now this graph at the bottom goes down to negative infinity, so we're definitely going to start off at negative infinity. This graph does not cross the horizontal asymptote, so the bottom part of the graph goes from negative infinity up to the asymptote, which is at negative 1. So these two branches down here reach from negative infinity to negative 1. All right, and anywhere there's an asymptote, I'm going to leave that round. But we have to be careful. The upper part of the graph does not start at negative 1. See how there's a gap here? It starts here at the y-intercept. Now remember, this y-intercept is not at 0 either. The y-intercept is at 3/25. Remember? So the upper part that sort of looks like a U or something is going to start at 3/25, and also we're going to put a bracket on it, and so we'll have 3/25, and from there it does go up to infinity. And again, I'll put a bracket on the 3/25 because this point is not an asymptote or anything. The graph includes that point. It is the y-intercept. It's on the graph, the point 0, 3/25. So the bracket shows that this is included as part of the graph, part of the range. Okay, now let's talk about increasing and decreasing intervals. As I go from left to right across this graph, part of the time I'm going downhill, and part of the time I'm going to be going uphill. This part goes downhill, okay, and then I pick up from here, and this is going downhill. All right, but then starting there, I'm going uphill. So this would be an uphill part of the graph. And then I'd have to pick up right here on the other side of the asymptote. And again, I find myself going uphill. So the two pink portions of the graph here are decreasing intervals, and the two green portions are increasing intervals. Now remember, when we do these intervals, we are only talking about x values. So be very careful. So x values. So looking at this arrow on the left, the x value of this is negative infinity because it's to the left forever. Okay, looking at this end of the branch, this is not going to be negative infinity. The x value is the asymptote. It is negative 5. Okay. Similarly, this arrow I'm about to draw right here, again, the x value is at the asymptote. So again, this is at negative 5. The end of this pink part is at 0, x value wise. This arrow is not infinity. That's negative 5. This is positive 5, all right, because it's at the asymptote. All right, this arrow right here that I'm about to draw is not negative infinity. This is also at positive 5 because we're talking about x values. This arrow over here will be positive infinity because it's going to the right. Okay, this is going to the left, negative infinity. This is going to the right, positive infinity. Okay, these values in the middle are the asymptotes and 0. Okay, so now it should be trivial. Our first increasing interval goes from 0 to 5. Okay, so I'll just say 0 to 5. Okay, and we will leave round parentheses on all of these because at the border point it's neither increasing nor decreasing. Now this other interval goes from 5 to infinity. Now for the decreasing intervals, or these pink ones, the first one goes from negative infinity to negative 5. Okay, and the second one goes from negative 5 to 0. All right, now in terms of symmetry, this has even symmetry. Even symmetry is the one where the y-axis splits it right down the middle, and the left side is a reflection of the right-hand side. So you can see, like, because of the way I just colored it, the pink and the green are mirror images of each other over the y-axis. So that makes this even symmetry. All right, and that's it for problem number 3. All right, here I've typed the equation into the Desmos app to see what it looked like. See how we did. So this looks pretty good. Let's see, can I zoom back? All right, so as you can see, this is what Desmos has, and this is what we have. So I think we nailed it. Okay, it's basically the same. Notice if we can zoom in really close on that y-intercept area, notice it does not touch 0. It's up here at 3/25. Okay, which is apparently 0.12. Here's what the graph looks like from space.